Okay, I've tried this question so many times, I can't do it. But let's give it one more crack. So you've got this, where D is a triangular region with the vertices. So let's draw this thing. So 0, 1, 0, 1. So 1 point is there. 1, 2, 1, 2. 1 point is there. And 4, 1, 4, 1. 1 point is there. So these are our 4 points. All right. So now we need to find the area beneath them. So we need to find, let's call this 1, 2. We need to find what 1 is. So 1, to find the gradient, is just rise over run. So let's just make this a bit easier for ourselves. This was 0, 1. This was 1, 2. And this was 4, 1. So to find 1, it's just going to be 2 minus 1, 0 minus 1. Whoa, no. 1 minus 0, which is going to give us 1 over 1. Yes. No, I think it does. All right, so that's what our gradient is. Our gradient is that. So we can say, therefore, y equals x plus c. We sub in our point. We can sub this point in. And because this is our y-intercept, so immediately we know that our c is going to be equal to 1. Because if we sub this into there, we're going to get 0, 1. Therefore, our 1 equals y equals x plus 1. Now let's solve our second equation. And our second equation is this line. So again, we go 2 minus 1 and 1 minus 4. And we get 1 over negative 3. So we get y equals negative x over 3 plus c. We put a point in. Let's put 1 and 2 in. So we're going to get 2 equals negative 1 on 3 plus c. Then we can go 2 plus 1 on 3 equals c. You're going to have to times the top and bottom by, so you're going to get 6 on 3. You're going to get 7 on 3 equals c. So therefore, our second equation is going to equal y equals negative x over 3 plus 7 on 3. And now we have to figure out, do we go that way or that way? So you could say, well, x equals from 0 to 4, and y equals... give me a sec. I think it's easier to go y exists from 1 and 2, and then x exists from this line to this line. I think that's the way we should do it. So in that case, we're going to do dy first. No, we're going to do dx first, then dy. We're going to do y squared dx dy. And in that case, our x's, this has to be in respect to y. What? Yeah, so y exists between 2 and 1, and x exists between you're going to have to put these in regards to y. Right? So this is going to become x equals y minus 1. And this one will become x equals negative 3y plus 7. I think that's where my mistake is. Wait, it should go, make that 3y, then that becomes negative x plus 7, then take that over to the other side, then you get negative x, then you get 3y plus 7 equals x. So that's correct, Damn it. So this is our lower bound, and this is our upper bound. So our lower bound, so it's going to be negative 3y plus 7 y minus 1 y squared dx dy. Right? Nothing works. Then you have to integrate this with respect to x. To 1 x y squared negative 3y plus 7 y minus 1 dy. This equals negative 3y plus 7 y squared minus y minus 1 y squared. This equals negative 3y cubed plus 7y squared minus y minus y squared. This is negative 3y squared plus 7y squared minus y cubed. Something has fixed itself. Plus y squared. Yes. Bueno. Then that's 3y, right? So you get negative 4 cubed, then that and that gives you 8y squared. Then you can integrate this with regards to y. and you're going to get negative 4y on 4 on 4 plus 8y on 3 on 3 between 2 and 1. Which is the same as negative y on 4 plus 8y on 3 on 3, 2 and 1. That's negative 16 plus 2, 4, 8, 64 on 3 minus negative 1 plus 8 on 3, which is the same as negative 16 plus 64 on 3 plus 1 minus 8 on 3, which is going to give you minus 15 plus 72 on 3. Which is going to give you 45 on 3 plus 72 on 3. Oh no. Which is going to give you 117 on 3. Minus. Something's gone wrong. Something's gone wrong. That equals 39. What went wrong? Oh, you're an idiot. That's what went wrong. You idiot. This should be 56. You're minusing, you idiot. Well, that could have stayed as negative 45. That was correct, wasn't it? You're still going to get negative 45 on 3 plus 56 on 3. Which is 11 on 3, isn't it? Is it? Negative 45 plus 56 is 11 on 3. And I think that's the answer. Is it? You did it. Sweet relief.